In the last two videos of this tutorial series, we are going to implement a way to remove objects from our grid after placement. Okay, let's get going. In our project right now, if we go to our placement system script, we are going to see that all the logic here in those methods is connected to the placement of the objects. So what we could do is we could slide up and add some sort of a bool flag, bool is removing. And we could try using this bool flag and adding it to those methods here, start placement, place structure, and so on. But obviously the names would now not match, and this could take a bit of time and it would be prone to errors. So we are not going to follow this approach. Instead, I want to separate this logic connected to the placement of an object outside of this script and implement it in a way that we can easily add next a new type of logic for the removal of those objects. What we will try to do is implement a state pattern. So the approach will be that we have some object that uses an abstraction, so some state, and that state can perform different actions depending on the subtype. So on the concrete implementation of the state, showing some public methods that are common to all the states. Okay, so now in our project, what we need to do is start refactoring our code. Our placement system not only covers how to place objects, but also actually adds the prefabs or instantiates the prefabs onto our map. We need to refactor this and extract this logic to separate scripts. So first of all, we are going to right-click, create a C# script called object placer. And let's open this script up. Okay. Now we have all this logic already existing inside the placement system, since we are creating this list of game objects and adding to it new objects that we want to create. So let's go to our placement system, let's select our list of game objects, place game objects, let's cut it, and we are going to place it in our object placer, the script that is responsible for this behavior, for adding objects and removing them from our map based on the calls from other scripts. Okay, let's go back to our placement system. Since we have removed this list, now some logic in our script will stop working. So we have added those place objects, the new objects that we are instantiating. So what we are going to have to do is we are going to create at the top of our placement system a reference, a serialized field to the private object placer, object placer. Okay, we're going to assign it through the inspector, but what I want to do is I want to slide it down to the place structure method, and here we are instantiating our object. So what we need to do is we are going to call place object placer dot, and we are going to create a new method, add object or place object. And what is going on here? We need to pass the prefab. So we are going to copy this data, objects data, selected object index prefab, and we are going to pass it as an argument to this method, this new method that we are creating. And this is the code that we are going to add there. But the problem is that we are also accessing the index or the count of our list that we do not have the access to anymore. So what we need to do is we need to return here int index, and we are going to set it equal to the place object method. And now we're going to take this index and we are going to pass it when we are calling selected data add object add, and we are going to pass it here. Okay, so we have our index. Now we need to remove those three lines. So game object, new game object, the transform, set transform to the grid position, and place game object, placed game objects, add new object. Now, one more thing that I can see here is we are passing the position, the grid cell to world. So we need to copy this, and we are going to paste it to our placed object. After the prefab, we are going to also pass the world position, so grid cell to world grid position. Okay, so now let's cut those three lines, Ctrl X, and we are going to right click on this place object method, quick action, and generate method. We are going to right click on this and go to the definition of this method. We are going to get here the game object prefab and vector3 position. So let's call it position. Okay, and I'm going to paste here our three lines that we have cut from the placement system, and we are going to need to return an index. So here we are going to instantiate the prefab, Next, we are going to set the position to the position that we have passed to this method. And now we are going to add it to our placed game objects. So what we need to return is return, and we are going to return placed game objects.count -1. We are not going to bother with removing those null values and adding them or replacing those null values with the objects after we remove objects. So you can implement this on your own to increase the performance. Okay, let's make sure that this is a public method. And let's save this class. Let's go back to our placement system. So we have handled the changes to the place structure method, and the rest of the methods are not using the object placer. Great, so let's save this. Let's go back to Unity. Okay, now this might be a bit less exciting, but because basically what we want to achieve is the same that we already have working. So let's go to our building system, right click, create empty. We are going to create object placer. Let's drag here our object placer. And if you can see, can't add script component because the script class can't be found, what we need to do is right click, create, for example, a new C# script. This means that the Visual Studio did not compile the files in our project. So now after this compiles this new behavior script, you're going to be able to select the placed object placer and place our script. The other reason for this might be that the name of the class is not matching the name of the file, but this is not the case in this example. Actually, if we are here in this script, we can add serialized field, so we are going to be able to see the list grow when we are placing objects on our map. Let's save the script. Let's go back to Unity, and now we can remove this new behavior script because we do not need it. And we can add to the placement system the reference to our object placer. So let's select it in our hierarchy. Let's drag here the object placer. And now, if everything went well, we should be able to press play in our project. And we should see that now we can still place objects. And inside our object placer, we can see that we are adding elements to our list, to our placed game objects. So everything works as intended as it was before. Every check works. Okay, this is great. So we have this refactored. The next step is to refactor the placement logic. So let's right click in the scripts folder, create a new C# script. We're going to call it placement state. And let's open this script up. Great. Now the whole idea behind the system is that the placement system directs the input manager and directs the object placer and other scripts. It sends them information, it exchanges information between those objects. So the previous system or the placement state should not know anything about the placement system. This is the idea. So that's why we have refactored this placement logic to the object placer, because now we can inform this placement state about the object placer, but not about the placement system itself. To make this placement state work, we are going to paste here a couple of fields. If you don't want to rewrite them, be sure to copy them from the GitHub repository from the placement state script. So what we are going to have here is the selected object index. This is the same that we had in our placement system. This was this int selected object index. But we are going to also have the ID reference, the grid reference, the previous system object database, grid data for floor, for furniture, and object placer, object placer. So again, we do not have any reference to the placement system, any direct reference. It will know about the placement state. Okay, so it should be obvious what those components will do, because they will do basically the same that they are doing inside the placement system right now. So to create this, we are not going to use a mono behavior. We are going to have a constructor, and this will be a simple C# class. To create our constructor, we do not have to type anything. If you are using Visual Studio, we can right-click on the name of the class, pick actions, and we can select generate constructor. And we can select now the fields that we want to populate. Selected object index is unique for the placement state, so we want to uncheck it, but the rest of the fields we want to populate, so let's click OK, and our constructor, very long constructor, will be created. We can right-click on this quick action, and we can wrap every parameter, align parameters, and we can now see them. Great. So basically this constructor will be called the same way when we are calling placement system start placement. This code will be called inside our placement state now. So what we can do is Ctrl+C to copy this code. We can go to, so from the start placement, the second line selected object index up until the input manager. So let's copy those lines. Let's go to our placement state. And we are going to create in this constructor the logic that we need. So let's paste those lines. We are going to remove them from the placement system soon. We are getting the object selected object index, and previously we have logged the error here. Instead of this, we are going to add here a new condition. If selected object index is greater than -1, this means that we have the correct index. As you might recall, the find index returns -1 if it does not find the index, this ID, in our objects data list. So in this case, we are going to paste here those values. Now what we did here is called grid visualization set active. We have not passed the placement state this grid visualization reference. We could, if we want different states to not trigger the grid visualization, but since most of our states will probably want to do that, we will have this as a common logic inside our placement system. So let's remove this line, and we had this preview system. So let's copy this name, and we are going to call preview system start showing placement preview. The last thing that we have is what happens if we do not find this index in our database. Well, we are going to add else, and we are going to throw an exception, new system.exception, and we are going to simply write here $. We're going to write no object with in ID, and we are going to pass in the braces the ID that we were given, because the placement state constructor takes the ID. We're going to maybe pass the small I ID, and let's finish the string. Okay, great. So this is not the role of the placement state to handle this kind of exception. It will throw it to our placement system. So if this happens, the placement system should react and should inform us that the ID is wrong. Great. So we have this logic here. Now the next thing that we need to have here is what happens when we want to end the placement. So we are going to add public void, and we are going to have end state. Remember that we want to have this general logic more than a specific one for our placing of the objects logic. So what happens when we end the state? Well, basically the same as we have in our placement system. We had this stop placement. So in our case, we want the grid visualization to remain inside our placement system class, but we had this preview stop showing preview. So we are going to copy this, we are going to paste it in our end state, and we had this preview system. This is our name of this reference. Now, next thing that we need to have is action. So what happens when we want to perform an action using this state? So we are going to create public void, and I'm going to call it on action. This will happen when we press our mouse button, and in our case, for the placement system or placement state, it will be placing object on the map. So we need to take in as a parameter vector3 grid position, because what we need to do here is basically the same as in the placement system inside our place structure method. So as you might recall, we had checked if the input manager has a pointer over UI, and we have calculated the vector3 and vector3 int. And the logic below is all about calling our placement state. So we are going to copy all this logic. We will not have the audio source here, but we are going to handle it soon. We're going to go to the placement state, and we are going to paste all of this here. As we can see from the first line, we also need to have check placement validity. So let's go to our placement system. We had this check placement validity method. Let's copy this, and let's paste it inside our placement state. Okay, so now everything should be working aside from this audio source play one shot. We're going to delete those for now from this script. This is one downside of this video. We are not going to add them until the next video. But for now, that's okay. We are going to slide down, and what we have this preview. This is preview system in our case. So everything here will be working as previously. So we are going to calculate the index. We are going to add to the grid data the correct position and the data, and we are going to update our preview system. Okay, So last thing that we need to have, let's slide below those two methods. We are going to have the public void update state. And this will also take a vector3 int grid position. So this will happen, or this will do the work of our placement system update method. So here what we did was, if our last detected position is different than the grid position, we have calculated the placement validity and we have updated our preview and updated the last detected position. So let's copy those 3 lines, not the last detected position setup. We're going to copy those and we are going to go to the placement state and we are going to paste those lines here. And we need to update the previous system. And we had this mouse indicator. We not needed this anymore, so we are going to delete this from here and from this placement system soon enough. Okay, and this is it. We have the update state, we have the onAction method, we have the end state, and we have the constructor. So now to implement this in a way that we have the state pattern implementation, we are going to save the script, right click on the class name, quick action, and we had this extract interface. And we are going to create 𝗏building state maybe. So let's call it this way, 𝗏building state. And we are going to select all those 3 methods. There will be by default selected end state, onAction, and update state. And let's create this, say OK. And now we are inheriting from this 𝗏building state interface. Now, if you are not using Visual Studio, you will have to create a new C# script and set it to be public interface 𝗏building state, and define void end state, void onAction with the same definition of the parameters, and void update state. And next you're going to go to our placement state and add :𝗏building state to it so that our placement state inherits from this interface. Okay, so the first part of this refactoring is done. Let's save this. Let's go to our placement system. And now we are going to make this script prettier by removing the unnecessary code and swapping it with our placement state implementation. So at the bottom of the parameters, we are going to create 𝗏building state reference state or building state. Okay. And now, when we go to our start placement logic, we had this logic extracted. From this, we had only this grid visualization. So let's cut it from this. And we are going to paste it just below the stop placement call. And we are going to remove all of this code beside the input manager calls. And we are going to call our building state equals new. And we are going to call placement state. And now this is a bit tricky because we need to pass all the parameters. So we are going to pass ID. We're going to pass the grid reference. We're going to pass the preview system. We're going to pass the database. We're going to pass the floor data, the furniture data, and we're going to pass the object laser reference. Again, I can right click on this quick action, align wrapped arguments so that you can see them more clearly. And this is how we are going to instantiate this building state. And automatically it will throw an exception if the ID is not matched in our database. Great. So let's slide down to the place structure method. Here we had received this mouse position and grid position. We have calculated those. And now all of this is unnecessary. We are going to delete this and we are going to call instead building state dot on action. And we are going to pass the grid position. And this will be it. So this is much more readable now. Next, let's go. We do not need to have this check validity. So let's select this, Ctrl-K, Ctrl-C to comment this out. We're going to slide down to the stop placement method. And all we did here is remove this preview, stop showing preview. Now we are going to call building state on end state. One more thing that we are going to do here is at the end of this method, we are going to set building state equals null. And this is important because now we're going to check here in the update, not if a selected object index is less than 0, but we're going to check if building state equals null. If this is the case, we are going to return. We are not going to perform any logic here. Now, if this is not the case, we are going to go to the this if statement. And in this if statement, we're going to remove the mouse indicator, the preview logic, and we are going to call here our building state dot update state passing the grid position. Great. Now we can slide up because we had this mouse indicator that we do not need anymore. We had this selected object index. We do not need this anymore. And the rest of those values, let's keep them for now. The audio source and my implementation of the sounds, it will stay here till the next video. The important thing about this refactoring is that now we are using this iBuilding state, and we can easily implement a new specific class that is inheriting from it, create a new method here that will instantiate a different state, and we can still use other logic that we already implemented here. Now we had this selected object index in the stop placement, so let's remove this. Now one more thing that I forgot to do is, while we are in the stop placement, we are calling the build state.end state, building state.end state, but we can have this as null. So we are going to check if building state is different than null, or if it is equal to null, we're going to return. Okay, now this should be better. So let's save this script. Let's go back to Unity. Great. Now we can go to our hierarchy, to the building system. Let's select our sphere that was in the indicator of our mouse cursor. Let's remove this since this is not working anymore. The rest of the scripts should work fine because we haven't created a mono behavior but a simple C# class. Okay, so let's press play. Great. So now we should still be able to select our objects to place. We do not have any sounds right now, but we can still place objects. We can still check if the placement is valid, and everything should be working fine. If we press escape, the grid will disappear and we can again enter the placement state, and everything should be working as expected. So this is great. This means that our refactoring has worked. If you have some issues with it, make sure that you check out this GitHub repository, the scripts there, to validate your scripts with mine. So in the next video, we are going to continue refactoring, or actually, we are going to start implementing the removal state, but we are going to also finish refactoring by adding the sounds back to our game. Okay, see you in the next video.